Saya, dear learners. I am Sir Miko, your science teacher. Let us explore the Newton's law of motion. Our most essential learning competency is to investigate the relationship between the amount of force applied and the mass of the object. Who is Isaac Newton? Isaac Newton was an English mathematician, physicist, astronomer, and an author who is widely recognized as one of the greatest mathematicians, physicists, and the most essential scientist of all time. What is a force? A force is a push or pull that causes an object to move, stop, or change direction. The measure of interaction between two objects. It is a vector quantity. It has a magnitude and direction. Magnitude refers to the general quantity or distance. Concerning the aspect of movement, we can correlate magnitude along the size of speed of an object while it is in motion. The size of the object or the amount is the magnitude of the particular object. Direction is relative measurement of the path of an object compared to another. Its orientation is compared to other relatively stationary or moving object. Let us start with the first law, the law of inertia. An object at rest will stay at rest, and an object in motion will stay in motion at constant velocity unless acted upon by unbalanced force. As you can see, these pumpkins will not move unless acted on by an unbalanced force. What is inertia? Inertia is the tendency of an object to resist changes on its velocity, whether in motion or motionless. As you can see on the picture, when the cardboard is pulled, the coin falls into the glass. This is because of inertia of the coin maintained its state of at rest and it fell into the glass because of gravity. Another example of inertia is unless acted upon an unforced force, this golf ball would sit on the tee forever. Why then do we observe everyday objects in motion slowing down and becoming motionless seemingly without an outside force? It is a force we cannot see, friction. Mass and inertia. Inertia is the property of objects to resist changes in motion. Mass is a measure of the amount of inertia. It is also the measure of the resistance of an object to change in its velocity. When forces are balanced, the acceleration of the object is zero. The net force is defined as the vector sum of all the external forces exerted on the object. If the net force is zero, the forces are balanced. When the forces are balanced, the object cannot change or move with constant velocity. Don't let this be you. Wear seat belts. Because of inertia, objects resist changes in their motion. When the car going 80 km per hour is stopped by the brick wall, your body keeps moving at 80 meters. Newton's second law, law of acceleration. The net force of an object is equal to the product of its mass and acceleration, or F is equal to ma. The acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. The net force of an object is equal to the product of its mass and acceleration, or F is equal to ma. More about Newton's second law. We must be certain about which body we are applying it to. Net force must be vector sum of all the forces that act on that body. Only forces that act on the body are to be included in the vector sum. Net force component along the axis gives rise to the acceleration along the same axis. Remember, force is equals to mass multiplied by acceleration. When mass is in kilogram and acceleration is in meter per second squared, the unit of force is in newtons. 1 newton is equal to the force required to accelerate 1 kilogram of mass and 1 meter per second squared. Newton's third law, action-reaction. For every action, there is an equal and opposite reaction. According to Newton, whenever objects A and B interact with each other, they exert forces upon each other. When you sit in your chair, your body exerts a downward force on the chair, and the chair exerts upward force on your body. There are two forces resulting from this interaction, a force on the chair and a force on your body. These two forces are called action and reaction forces. The size of the force on the water equals the size of the force on the fish. The direction of the force of the water backward is opposite to the direction of the force in the fish forward. Consider the flying motion of birds. A bird flies by use of its wings. The wings of the bird push air downwards. In turn, the air reacts by pushing the birds upward. The size of the force of the air equal to the size of the force of the bird. The direction of the force of the air is opposite the direction of force of the bird. Action-reaction force pairs make it possible for the birds to fly. The baseball forces the bat to the left, and the bat forces the ball to the right. The reaction of rocket is application of the third law of motion. The various fuel are burned in the engine, producing the hot. Sample problem. A 3.5 kilogram papaya is pushed across a table. If the acceleration of the papaya is 2.2 meter per second squared to the left, what is the net external force exerted to the papaya? Given m is equals to 3.5 kilogram. Acceleration is equals to 2.2 meter per second squared to the left. Required. The force. Equation. F is equals to ma. Solution. Force is equals to ma. Distribute the given to the formula 3.5 kilogram multiplied by 2.2 meter per second squared. Our answer is 7.7 kilogram meter per second squared or 7.7 Newton to the left. Suppose a grocery cart has a mass of 0.45 kg is pushed with a force of 90 Newton. What will be the acceleration of the grocery cart? Given mass is equal to 0.45 kg and then force is equal to 90 Newton. So we have the required, the acceleration. So next is the equation is A is equal to F divided by m. Solution. A is equals to F divided by m. So 90 kilogram meter per second divided by 0.45 kilogram. The answer is A is equals to 2 meter per second squared. So goodbye learners. May the mass multiply acceleration be with you. So that is the course. Thank you.